Today we're going to be looking at the distributive property. We talked about the distributive property a little bit during our big properties video, but now we're going to focus on the distributive property and a little bit more just in itself. So to review, the distributive property says that for any numbers, and for today we'll use A, B, and C, that A times the group B plus C is equal to A times B plus AC, just as B plus C times A is equal to BA plus BC. Notice that we kind of did the associative property, not associative, sorry, my apologies. The commutative property by changing which was first, the B plus C, or the A. And so therefore here we distributed the A out there, we distributed forward, and here we distributed back when we did the commutative property, not the associative. That was my bad. It can be confusing to mess up the associative and the distributive because they both involve parentheses, but we are looking at just the distributive property. So, and it also works over subtraction, so if we had A times B minus C, that would be AB minus AC, or again, if we did B minus C times A, that would be the same as BA minus CA. Again, distributing forward, distributing backwards. So for example, if we had 3 times 2 plus 5, and we were to evaluate using the distributive property, we would multiply 3 times 2 plus 3 times 5, which is 6 plus 15, which equals 21. If we were to use our order of operations from earlier, and we said that this was 3 times 7, that's also 21. So there we kind of checked, yes, this does indeed equal what it's supposed to. Also again, if we took 4 times 9 minus 7, and we distributed, we got 4 times 9 minus 4 times 7, we took 36 minus 28. 36 minus 28 is 8. If we did it with our order of operations, we did our grouping first, so 4 times 2. 4 times 2 is 8, which we said equals 8 when we use distribution. So we know that this works. We know we can trust this method, all right? Let's look at a couple more examples. Now we're going to involve variables into the mix. So we are going to use the distributive property to simplify. So if we said that we had 7 times the group 3w minus 5, 7 times the group 3w minus 5, and we distributed, that means that we would have 7 times 3w minus 7 times 5. So then we're going to take here and multiply 7 times 3 because we only multiply the coefficients. We only multiply what looks like each other. So 7 times 3, 21, and smack on the w, minus 35. So we distributed 7 times 3 minus w minus 7 times 5, and we simplified. Let's look at this example. If we did 6v squared plus v minus 3 times 4. Here we're going to back distribute. We're going to distribute to all 3 but kind of do it backwards. So we're going to have 6v squared times 4 plus v times 4 minus 3 times 4. We're going to go through and simplify each of these terms. So 6 times 4, that's 24 v squared, plus 4 times v, 4v, minus 12. And there we go. We have simplified using distribution. Alright, why don't you try one by yourself? Alright, welcome back. I hope that was successful. Now, a couple of definitions that we need to get through so that we can do some more distributing and some more evaluating. So, if we have a concept called like terms. Now, you've probably used like terms several times before, but like terms are terms that contain the same variables with corresponding variables having the same exponent powers. So let's look at this. So if we have the phrase or the expression 6a squared plus a squared plus 2a. And we're going to look for like terms, terms that have the same variables, so the same letters, and with those same letters they have the same exponent powers. So we look and we see that this 6a and a squared, these are like terms. We could consolidate those terms if we wanted to. We could say 7a squared. Those are like terms, 6a squared and a squared. Now, if we look at the a squared and the 2a, yes, it does have the same variable, but is it to the same power? This is to the second power. This is just to the first power. There's just a 1 hiding there. These are unlike terms. These are unlike terms. So, if we were to want to combine our like terms, if we combined our like terms, we would be looking to put things in what's called simplest form. Something is in simplest form when the expression has no like terms or parentheses / grouping symbols. So something is in simplest form if the expression has no like terms or parentheses or grouping symbols. So for example, if we were to simplify 17u plus 25u, 17u plus 25u, we can kind of use the opposite of distribution, and we have 17 times u plus 25 times u. We could write this as 17 plus 25 times u. Add that 17 and 25, so we'd get 42u. Or if we knew that with adding variables, we added the coefficients to get 42u. There we go. Let's look here. Let's look if we have 6t squared minus plus 3t minus t. Here I see that we have t squared, t, and t. I'm going to take 3t minus t. I'm going to combine that. 3t minus t, that's like 3t minus 1t. So I would have 6t squared plus 2t. And now we look. I don't have any like terms left. I don't have any grouping symbols left. So therefore, I have put things into simplest terms. Why don't you try to simplify something? All right. So let's look now at our homework. Let's look at our practice problems. Our practice problems, we're going to be looking at page 157 in our iBook. Page 157, numbers 13 through 37, odd, no 21 and 23. We're not going to do 21 and 23. Those have us do some things that we're not going to cover that are kind of silly to use distribution for. So we're going to do 13 through 37, just the odds, but we're not going to do 21 and 23. So we'll start with 13, where we use the distributive property to simplify 4 plus 5 times 6. So we're going to say that's 4 times 6 plus 5 times 6. 4 times 6, that's going to be 24. Plus 5 times 6, that's going to be 30. 24 plus 30. We add that together, that's 54. We box our answer, we skip a line, 15, and we go on from there. Again, 13 through 37 odd, skip 21 and 23. Have fun.